All right, we're going to take a journey, but not through space. We're going through time, like all the way, to the very, very end of everything.
I mean, it's one of the biggest questions out there, right? How does all of this, everything, finally end? Is it going to be some big, fiery collapse, or more like a slow, quiet fade to black? Maybe it's something we can't even wrap our heads around. Well, believe it or not, science is starting to give us a picture. And yeah, it's pretty stunning, and honestly, a little terrifying.
And this quote, I think it just perfectly sets the mood for where we're headed, because that's exactly where we're going, into an age of cosmic darkness and total silence. But who knows, maybe we'll find some incredible things there.
Okay, so to cover these just insane timescales, we've got to speed things up a lot. Our little trip through time is going to be exponential. We'll double our speed every 5 seconds, so yeah, you're going to want to buckle up for this one. So, before we just jump into the deep end of time, let's kind of get our feet wet. Think about this. In just 50,000 years, a blink of an eye really, the constellations you know and love, they'll be gone, drifted apart. A million years from now, those famous Apollo footprints on the moon, they'll be erased by tiny meteorites. It's just a little taste of a big cosmic truth. On these scales, absolutely nothing lasts forever. Okay, let's hit fast forward. We're jumping way ahead to the first big finale. You know, our whole universe is basically defined by starlight, right? Well, that brilliant era, it's coming to an end.
And this is how it happens. This is the life story, or I guess the death story, of pretty much every star, including our sun. In about 5 billion years, it's going to run out of gas. The core collapses, but the outer layers, they puff up into this massive red giant, big enough to completely engulf the Earth. And all that's left behind is this tiny, super dense corpse of a star, what we call a white dwarf.
Now imagine that happening to every single star, one by one. We enter this new phase called the Degenerate era. And man, that description is just perfect, isn't it? The universe becomes a cosmic boneyard with nothing but the cold, dead remains of stars.
But here's the thing. It's not totally dark just yet. The universe is now filled with these, well, you could call them zombie stars. These white dwarfs and neutron stars, they're still glowing faintly, with leftover heat. They're the only lights on in this huge empty void. It's like a ghost universe.
Of course, even that ghostly glow has to fade. Eventually, that white dwarf will cool all the way down and become a black dwarf. Just a cold, dark, dense ball of matter. And here's the really wild part. Black dwarfs don't actually exist yet. Not a single one. The universe is still way too young for any star to have cooled down that much. Kind of puts things in perspective, huh?
So, with all the stars gone, something else takes over. A new power rises in the dark. The most massive, most extreme objects in the universe finally get the stage all to themselves. Welcome to the reign of black holes.
Just look at this number. It's so small it almost doesn't make sense. That tiny, tiny percentage. That's the fraction of the universe's entire life where things like stars and planets and warmth, life, can even exist. That's it. It's an unbelievably small window. We are literally living in this fleeting, precious moment, a cosmic springtime.
By now, the universe looks completely different. Galaxies like the Milky Way, they're gone. Instead, you have these zombie galaxies. At the center is a supermassive black hole, and orbiting it is just a swarm of smaller black holes, all slowly spiraling in for trillions of years.
And you might think it's silent now, but no way. This era is anything but quiet. I love this analogy. The biggest show in town is black holes merging together, and when they do, they are so violent they actually bang on the fabric of reality.
So what does that even mean, banging on space-time? Well, as two black holes spiral closer and closer, their gravity is so intense, it creates these powerful ripples in space itself. We call them gravitational waves. It's like space is ringing like a giant bell. And get this is the crazy part. If you were somehow close enough, your own eardrums would vibrate with the stretching and squeezing of space. You would actually hear the collision. All right, let's go to the final act. Because even these cosmic titans, the black holes, they don't last forever either. We're now jumping so far into the future that the very idea of matter starts to dissolve. And it's all because of this really weird quantum effect called Hawking radiation. Okay, so all around us, pairs of tiny particles are popping into and out of existence constantly. They usually just cancel each other out. But right on the edge of a black hole, sometimes one particle falls in and the other one escapes. That escaping particle, it takes a teeny tiny piece of the black hole's energy with it. It's the slowest leak you can possibly imagine, but given enough time, we're talking trillions of years, even the most massive black holes will just evaporate. So, what's behind all this endless expansion, this slow cooling death? Well, it comes down to what our universe is actually made of. And the answer is mostly stuff we don't understand. Everything we can see and touch, normal matter, that's only about 5%. The rest is a giant mystery, dominated by this thing called dark energy. It's like an anti-gravity force that's constantly pushing everything apart.
And whatever this dark energy turns out to be, that's what will decide how it all ends. If it gets weaker, gravity might pull everything back together in a big crunch. If it gets stronger, it could cause a big rip, literally tearing atoms apart. But based on what we can measure right now, the most likely outcome is this runaway universe. Just endless expansion into a cold, dark, empty nothingness.
So, is that it? Is that the end of the story? Just an eternity of cold and dark? Well, maybe not. For our last chapter, let's get a little weird. Let's talk about one of the most out there ideas in all of physics. What if someone, or something, could find a way to escape?
The physics, strange as it sounds, seems to hint that if you could concentrate a mind-boggling amount of energy into one tiny spot, you might be able to create a brand new baby universe. It sounds like sci-fi, but when you're facing the absolute end of everything, that could be the only lifeboat left for a super advanced civilization.
But if there is no escape, then the universe continues its slow march to the end. The very last supermassive black hole will finally finish evaporating, and it won't go quietly. It'll disappear in one last, gigantic burst of energy. For one final, beautiful, fleeting moment, the dying cosmos will be filled with light.
And then, after that last flash, nothing. Silence. The universe finally reaches perfect balance. There's no heat, no energy flowing, nothing happening, no change at all. And if nothing ever changes, then concepts like before and after just stop making sense. The arrow of time just dissolves. Time itself becomes meaningless, and nothing happens. Forever.
And that brings us right back to where we began. We can finish that Helen Keller quote now. After this whole journey into all that darkness and silence, there's a strange kind of peace in this idea, a sort of contentment. The story of our universe is over.
But does it have to be? This whole journey leaves us with one last massive question. Is the end really the end? Or is it possible that somewhere in that final timeless emptiness, the seeds for a brand new universe, a new Big Bang, are just waiting for their moment?